Yo, what's up guys, gals, can you hear me? Gomboss, I think it's just you and me at the moment. Oh no, there's a few other people that are rocked up. Yeah, I don't know what's going on there. Ah, Burger, oh my god. Nice to see you. Gomboss, thanks for coming in. Yeah, sorry, I've been mucking with Streamlabs profiles and trying to get the Stream Deck to sync up, and there's weird stuff going on because we're now doing the Meterpreter thing. I flicked over to my different profile on the Stream Deck and everything was kind of weird, so maybe that was what the problem was, and I thought it was on but it's not, and anyway, hopefully you can hear me. Can you hear me clearly? Is it loud enough compared to the music? Just a quick sound check before we continue. Tonight's tea is Gyokuro again, so make sure you got yourself a nice brew, because hacking with our tea is very uncivilized. Although technically we're not going to be hacking tonight. We are back on the development train. It has been a long time since we've done a stream on Meterpreter, and so I'm going to have to recoup a little bit, figure out where we got to. From memory we were mucking with transports, we just finished doing HTTP transports, and what I want to be able to do is build out some more of the transport commands, so things like transport add, transport next, and make sure that the rolling over of the transports behaves correctly, basically. So that's the plan. Yeah, anyway, thanks for joining in. There's another really important thing tonight, which I haven't done for a few days and nights, partly because I've already had enough, but tonight we're back on the chocolate. Decided to pull out the 78% tonight because that's the only option I had. So it's a hacking stream. Can you? I knew you were coming. I knew you were coming in to troll me. Your message was a dead giveaway. Welcome, Barney. Thanks for coming back, mate. We're just going to have some chalk before we kick things off. I hope you guys have brews respectively. But yeah, transports I think is where we're going to start, and then what we're going to do is lay the ground to make sure that we've got all of the other bits and pieces in place, so that on the next stream where we do dev, we can actually start working through channels. That's the plan. So not this one, but the next one. Do I deserve the chalk? Yes. Hey Rasta, good morning to you. We're just getting through the usual kickstarting of the stream where I eat in front of you and speak with food in my mouth while drinking expensive tea. And whinge about the fact that I had to muck with my settings again. I recommend it if anyone out there. Anyway, what I had to do, no climbing pictures, no streaming. I am thinking of doing a live stream from a climbing gym just for funsies at some point, but that day is not today. Anyway, so here's what we're going to do. Yeah, no worries, man. I had to go back to my dev-env and reset up listeners and whatnot. So a couple of things have been tweaked slightly, but nothing in the code really has changed since we last looked. Okay, so let's get into it. It is 7:36 Queensland time. I'm going to try and stop at 9:30 at the latest. Now, as always, be sure to sing out if you have any questions to make sure that everything makes sense. But as you can see, we have a bunch of listeners set up. I have the standard native ones, but I've got 1, 2, 3, 4, 5, 6 listeners. So CLR2 and CLR4, TCP HTTP. So all of the listeners are sitting there ready to go. The XP wallpaper is back. Yeah, I'm thinking of changing it though for the next one. Actually, well, this is episode 29. So maybe we'll come up with a nice quirky one for the 30th, which means 60 hours of development content so far. Wow. Okay. So everyone's got their tea. Now, back over here. I just had to generate URIs, I think because something changed or something. I wasn't quite happy, I was getting errors. So I just regenerated URIs and wired them in to make sure that our payloads continue to work, and just to demonstrate that they do. Whoops, sessions -x. So there you go. We do have a session. I don't have a session command. So we are OJ at failtrain. Sysinfo should work. PWD should work. Okay. So all good. All good. So before Milo, yeah, Milo. I haven't had a Milo for quite a while, but I'm not gonna lie, it's pretty good. Okay, let's just make sure that TCP works as well. Let's build that. I just want to make sure that they both work, so when I flip transports from one to the other, it does actually behave. Okay, we got a sysinfo. Yeah, okay. So that's good. We know that TCP and HTTP are working. So what I'm going to do is I'm going to start with TCP, and we're going to flick over to HTTP. Actually, is that the best thing to do? Yes, yes it is, because to begin with I want to flick over to a handler that understands the difference between staged and stageless. So here's a question actually. Maybe before we do this, flicking between the transports, let's make sure that when we terminate MSF that our sessions come back. So let's have a look at that. Welcome Atwolf, thanks for coming in. Yeah, classic time zone shenanigans. Although I did try and give everyone warning. He's Victorian. Alright, so I am going to, for now, I'm going to flick back over to HTTP, not even HTTPS, we'll just stick with HTTP. And doing this, hang on, I'm going to have to do the same thing here. Let me just paste this in here because the URIs did have to change. So let's just make sure HTTP works. Okay. Ah, have you noticed that system language didn't come up there? Oh, crap. Did you see that? System language is blank. Why was that blank? Like beforehand we had 4449, which is HTTPS. That came back here. But when we ran it here, sysinfo, and now it works. I don't know why it didn't work before. That's very strange. Okay. Now I'm not sure what's going to happen when the transport doesn't work. So what I'm thinking of doing is when we go into metserve 3.5, in our server we have a loop here that attempts to connect, right? So register, and while we're running, we try and connect here. So this would be packet dispatch loop, that's where we need to go. And inside here we're obviously checking for session expiry and barfing if the session has actually expired. Here we try and receive the packet. So what I'm keen to know is when we go to HTTP transports and we go to receive packet, what happens in the case where we're unable to connect. So let's run this. Now, all I'm going to do is, actually let's BG that, and I'm going to exit -y, and I want to sit here. Oh, here we go. What happened here? Exception settings? No, view details. Exception has been thrown by it's unable to connect to the remote server. So that was thrown by what? Where was that thrown? System.runtime. I want to figure out exactly where that barfed. I'm assuming it happened like right down in the guts where we were attempting to, like right down here. Yeah. So if we catch exception E, and what I'm going to do is I'm just going to break system.diagnostics.debugger.break. That's the slow way of doing it, but I'm going to do that anyway. So I want to see what happens when an exception is thrown. Not all paths return a value. That's true, they don't. So let's return null because we didn't actually get a packet. So in our packet dispatch loop in the server, request doesn't equal null. Then we handle it. But if it's definitely not null, we handle it, and otherwise we just bail out and say we should roll over to the next transport. This is where it's going to get tricky because like our current transport, if it hasn't successfully connected in the case of HTTP, then basically we need to go. So this is where it's kind of quirky because the idea of being connected in HTTP land doesn't exist, but we're probably going to have to maintain some state to keep track of whether or not we're actually part of the session as it currently stands. So it's interesting, huh? Anyway, let's see what happens when we run this. Should that... Oh. Got to fire this back up again. We clearly don't handle cases where the stager can't connect. Let that run up. Okay. Exit -y. Let's see what happens. See, that didn't actually get caught. I wonder why that's the case. Is that paleo granola, Rasta? Exception has been thrown by the target of an invocation. Socket exception, no connection be made at the target. Now, I'm really keen to know where this happens. Target site. It's got to be in here somewhere, right? I wonder if it's because we're continually using this web client. I still would have thought that something would have come through in here. Could also be this create web client call, hey. No, actually, that's probably not the problem. Yeah, I'm really not sure what the story is. Ah, maybe it's in... Oh no, it wouldn't be there either. Okay, well let's go back to the stager. Because what I'd like to do here, we're just going to go try. I'm going to catch the exception here. And I'm just going to write it to the console. So console.writeLine e.stacktrace. So I'm keen to know the whys. And that's going to break as well. Because I don't have my listener running. Apple and raspberry. Ooh. Sean made some... Oh yeah, Paleo granola was magic. And it's really filling too, which is awesome. Yes, well, Rusty, you could be picky and suggest stuff like actually using the standard error, but nah. Alright, let's try that again. Exit -y. Let's have a look. Shit. Let me go back to program and where is it? Load stage. system.diagnostics.debugger.break. That's annoying, isn't it, mate? Oops, I've done it again. Okay, should be better this time. No, it's still not loaded. Okay, there it is. Okay. Ooh. It actually happened in receive packet this time. Okay, e.stacktrace. So yeah, download data. See, and this is fine. Like this is basically what I would expect to see. So we can let this run. Request doesn't equal null, so we need to go to the next transport. So if we come down here and we say next transport, we disconnect from the current one, where we remove our SSL validator step. And what are we doing here? Our transport index should currently be 0 because we've only got one, and then the next one should also be 0. And then we re-reference our cell, and then we try and connect. Now, here's the thing, right? What happens in this particular case is that we should try to connect continually with a classic sort of get, but you'll notice that in HTTP transports, connect kind of doesn't do anything. This dot is connected. So the current transport says that it's connected when it's not. So herein lies the problem, right? If we say that we're connected and then we go back into our packet dispatch loop straight away, we're going to end up with the same error being thrown, and we're just going to keep cycling through the transport. But what we actually want to do is continue trying to connect to the endpoint while it's down, and stick within this loop, because this is our transport retry loop, right? So connect is connected is basically currently true. So we need to do some state management in here, right? So when we disconnect, we actually want to set is connected to false, right? So disconnect, we're going to go this dot is connected is false. So we've got to maintain sort of some state, right? Let's make this a get and a private set. Now when we connect, we're going to try, we're only going to add this callback thing when we know that we have actually connected. Does that make sense? Excuse me. So what we should probably do is make a straight get request to the endpoint using the current web client, which is associated with the transport. But you see, we need to make sure that we disable SSL validation at this point. So we probably need to make a request after this, and if we're able to successfully connect, then we're technically connected. Otherwise, we need to effectively remove this callback and return to the caller, if that makes any sense. So we're going to wire that in then by default. And in order to remove potential duplication, I'm going to have two private void add SSL verification hook without any, and we'll do the same with remove So the reason why I'm doing this is because it's not particularly intuitive what these things are doing. Plus, I'm actually keen to make sure that we keep track of whether things are hooked. So if this.ssl hooked, then okay, and then we're only subscribing when we're supposed to, right? If we're not, sorry, if we are hooked, cell hooked, then we unsubscribe and basically do this. Whereas here, if we're not hooked, then we hook it. Okay, and that means that we can kind of call this ad hoc in various orders, and it should continue to work, right? So we want to go remove server validation, remove SSL verification, add SSL verification. Okay, and then what we can do, that's no longer always true. So I want to add the SSL verification hook, and then we want to attempt to connect to the endpoint just using a straight get. The problem that we've got though is that we want to hit the endpoint and receive a packet. And if we can do that, then effectively what we need to do is, because we're going to end up receiving a packet with a packet decryptor as part of our usual process, right? Packet encryptor, I should say. So this packet encryptor, what happens? Do we assume that this is specified? I think we do. Oh no. So we can technically pass in null here, and that would be okay. Although it does look a little bit dangerous, doesn't it? So if we passed in receive packet like this, so we need to have a local variable called hooked private bool SSL hooked. Is this all making sense? I hope it's making sense. Now, we want to try and receive a packet, and if we receive a packet, we need to process it, right? And once we've received that packet, if it's not null, we need to process it effectively on the next loop. Otherwise, it kind of gets gobbled up. Oops. Oh, I've just got a new follower, have I? A couple of new followers. Oh, I know that name. That name is familiar, but I won't call you out. But thank you for the follow, both of you. I don't even know how to say it. Caciatris, and SM Bolster. Thank you very much for the follow. Very kind. So what I want to do is, once we've received this packet, like if we do successfully receive it, we're going to have to process it. But we want to process it as part of the current sort of packet loop. Yeah, I was close. Cacia. I'm going to say it's Cacia, or is it Katia? No? I'm terrible with reading names off this thing. I'm really sorry. Borderline offensive, isn't it? Katia. Okay, cool. It's nice to see you on stream. On stream, I should say. Righto, so we'll just say something went wrong, bail out. Now what I will do is we're going to have to keep track of the packet that we've just read for when all of the things kind of happen behind the scenes and our transport kicks off. So we need to actually connect and read a packet to know for sure that we can actually do stuff. But then we need to handle that packet. Oh, it means huntress. Really? There you go. How fitting. How very fitting. Okay, so var packet equals receive packet. Right. And then we can say if packet doesn't equal null, then this dot is connected is true. But we also want to keep track of the packet. And given that we're probably only going to be handling one at a time, actually, is that fair to say? We know we're going to be reading stuff on a single thread, so maybe what we need to have behind the scenes, just to make sure that we're keeping track of stuff, is like a using collections, a queue of packet. We'll say incoming packets. Oops, null. Alright, so then we get this dot incoming packets is a new queue of packets. And then what we can do is we can, once we connect, we can say this dot incoming packets dot enqueue the packet. This at least allows us to handle the packets as they're coming in, right? And this maybe will give us the ability down the track to have a queue of packets that are read and handled sort of in different ways. But what we want to do here is we want to say if this dot incoming packets dot where are we? Is there empty? No, count. So if we have a packet, then basically what we want to do is return this dot incoming incoming packets dot dequeue. So if we did get a packet off the previous request, we're just going to send that back instead of going through this, which I think makes sense. Hey Eric. And so that will hopefully give us the ability to like simulate actually connecting while maintaining the ability to keep track of whether or not things have successfully connected behind the scenes. Right? So quickly ducking back here again. So current transport connect. Yep. Yeah, so here we say, we always return, is it connected, yes or no. And we can actually bail out of this when the session expiry bails, at which point, transport expiry bails, at which point we should flick over to the next transport. And that's effectively what we're trying to do there. So what I'm going to do is validate that this stuff is doing its thing correctly, and see where it goes from there. So we will make sure that all of the things are behaving properly. It could be a slightly tedious process, but anyway. So add, is it hooked? No, it's not. So hook it, indicate that it's been hooked. Now we're going to try and receive a packet, and it should be okay. All right, we're not actually parsing it, we're just queuing it up. And then that means that when we get to here, the first packet that comes out should be what's in the queue. And then from there, we shouldn't actually hit that again, and things should work as expected. There's that system language thing again. I wonder why that's not coming out. Okay, so now what we want to do again is make sure that we are catching the exceptions in the appropriate place, and returning null will bring us back to the dispatch loop. Packet dispatch loop should bring us to here. We hope. That's the theory, right? So. Okay, cool. So we're back to next transport, which is good. So we should disconnect from the current one, which means we remove our hook, indicate that we're no longer connected. Go to the next transport, which is technically our current transport. Figure out the transport expiry for this particular transport, which is quite a while, a long way away. Oh, that's UTC, so it's probably not that far. And now we try and connect again. So we re-add the hook. Ooh, I've missed a step. We try and receive a packet, and it should come out null. Okay. So what I've missed here is we need to remove the verification hook. Because we kind of don't want that sitting there overhanging when we're not technically connected. We're not necessarily aware of what's going on in the greater server context. So we don't just want to leave it sitting there, particularly if we end up removing the transport itself and kind of leaving it hanging and always hooking in, and it ends up being a resource leak too. Okay, so that's actually behaving as I was hoping it was going to behave. So I'm just going to leave a breakpoint here. We're going to kick this off again. Leave a breakpoint here. We should see this when we first connect. Once this is all set up. That's right. For some reason my Postgres isn't running. Alright, so let's spin that up. We should break once. Okay. Now, let's just exit -y. Okay, so next transport. Disconnect, go to the next transport, loop. Transport expiry, data blah. And it's going to try and do it again. And now it's saying, wait. Check the expiry and keep going. Alright, so that's good. That's sitting there now polling. Hopefully we should get out here once we fire this up again. Wait for it. Wait for it. T. Boom. And you'll see that TLV encryption has been specified. Again, now the interesting thing about this is that when the session bails, we end up with TLV encryption again. Did it work? Yee! Woohoo! That's pretty cool. So, we basically have a transport now that reconnects. At least, whoops. I didn't mean to do that. F9, yes. Let's just, well, let's exit -y and fire it up again, and we should see a session come back in. Let's have another piece of chocolate in celebration. And come on. Oh, there it is. Session 1 opened. And what I was really keen to see was this, attaching orphaned / stageless, so it knows that it has been staged already, and so the staging process doesn't happen again. Pretty cool, huh? That's good. Alright, so I'm going to exit that session. And what I'd like to do is make sure that it works with HTTPS as well as HTTP. Particularly given the SSL verification shenanigans that we're doing. So, let's run that. Far up. Still running. And there it is. All right. Okay, I'm happy with that. I've got confidence there that we're actually doing the right thing behind the scenes with packets now, if that makes sense. One question I still have in my head is to do with the packet decryptor. Because clearly I typed that wrong. Read a packet encryptor. So let's have a quick gander. So this packet encryptor is, it's a bit cheeky kind of setting it to null, implying that we can't handle packet encryption. So maybe we should do something inside our packet here that says if encrypted. Let's put a little to do here. If we don't have a packet decryptor, then we should probably bail out. Sorry, decryptor. So this encryptor gets passed in, right, as part of this server. And what I'm keen to know is, how is it actually set? Ah, you see this? So the packet encryptor, when we end up with an AES key on the packet encryptor, which is part of the server itself, then this is probably it here, right? So we end up with this core negotiate TLB encryption. Ah, okay, so we get this in and we call generate new AES key, which returns random bytes. And then you set the key on the encryptor. Now, what's interesting here is that if we set an AES key, what happens? Ha, there you go. That's what saved us just there. See that? If we set a new AES key, we basically straight away say, we're going to disable encryption to make sure that we return a non-encrypted packet. Yeah, man, this music is pretty serious, isn't it? I think this is another Beat Saber tune. So yeah, any questions about that? Ooh, that's not a Beat Saber tune. Yeah, okay. Alright, so what I'm going to do now is I want to do exactly the same thing but with TCP. There's going to be a little bit of a trick here though, because if we connect to a TCP listener is not currently smart enough to know that a stageless connection is going to come back. So the first packet that it tries to read off the transport is going to be wrong. Because we're going to be sent a stage effectively, right? Now, let's build that, and while that's building, I'm going to go in here. Okay, so if we're not connected, then we do this. Then we try and reconnect. If connected, then we wrap the client. We should probably actually put this dot is connected. It's true at this point. Ah, no, we don't need to do that because it actually has the logic in it behind the scenes, so that's fine. Okay, so the question then becomes, what happens when we connect? If we can connect... Now, what'll happen is, when we try and receive the packet, it's going to be full of junk. So the question then would be, if we're able to wrap the client, maybe here is where we go flush the stage. I can't remember how we do this in native land. It might be worth us actually having a dive. The problem that we've got though is that we're going to be assuming that we're going to get a TLV packet off the wire. So yeah, I'm thinking what we need to do. The thing is, we can't assume that we're going to be connecting to a stageless listener either, or a stage listener. So we need to somehow detect whether or not we have received the stage, or whether we've received a legitimate packet. This is where it's going to get a little bit tricky. Is this making sense? Do you have any questions? Righto, so I'm going to leave this here, and we're going to hit go. Oh, I didn't build it. Boo. Okay, now I built it. Okay, so are we connected? Yes, we are. Just carry on. Okay, so if we go exit -y, I'm hoping that we'll end up here. Aha. So what happened there? Where did we get load stage, invoke member, reflection, runtime info? Hang on, it's impossible to read. Yeah, so the question then is like exactly where is the source of this blowing up? Because the exception that we have is clearly source array was not long enough. Source. Okay, so this has got something to do with us reading information out of the socket. So my guess would be it's in here. Okay, let's just can this for a sec. And then we're going to go catch exception system.diagnostics.debugger. You know what I usually do? Instead of typing all this out, I just go int x equals 0 and then hit a breakpoint like that. It's kind of dirty. Nothing is ever long enough for some people. Amen to that. Okay. Let's kick this off again. Try again. So this is basically I was trying to bake in resilient transports. And then once we've got resilient transports, we can flick between transports manually, knowing that they will roll over and behave as you would expect them to behave. But one thing that we don't have right now is a stageless TCP listener. But that's something that will have to come down the track for various reasons, because we can't generate payloads. We can't currently generate stageless payloads either. Not that that's a huge problem. I mean, we can do it at least at the source level. We just can't compile it. But again, that will come. Okay. Exit -y. Here we go. Righto, so here is where we should return null, which is good because the packet should end up doing exactly what we would expect. Go to the next thing, we disconnect, dispose, kill everything off. move to the next transport, which is the same as the current one. And then we try to connect. So if it's not connected, which it shouldn't be, create a new one and try and connect. This is going to throw an exception too, right? Yeah. Okay, so we need to catch the exception here. Okay, so try catch. Now again, I'm going to leave exception E in here for now, just so that we can see what it is. Debugger.break. And let's do that again. Yeah, that's not going to work because I still don't have my listener running. You guys are quiet tonight. And what a surprise that we don't have as many people here now that we're doing development. It's as if you guys like the hacking stuff. Which I get. Okay. So the exception we got there was like we're trying to read off the stream and we don't get what we're expecting, which is why it bails. So the exception, interestingly enough, is of type e.getType is a argument exception, which is a little bit obscure, right? Copper Beardy, welcome to the stream. Thank you for joining in. I agree. It's all fun. I thoroughly enjoy it. So let's let that run. Here we go. We've broken again, and we should see a thread.sleep effectively for however long. Retry wait. This is interesting, isn't it? Retry wait is 10. Why have I got plus here? So thread.sleep takes milliseconds. We specify seconds. We should be timesing by 1,000, not adding 1,000. What a fool. Maybe given the fact the interest isn't there as much, maybe it's worth starting to do dev outside the stream and then coming back fortnightly with a summary of what was done. Look, I have thought about doing that, but I've asked for a wider opinion. I've done polls on Twitter. I've spoken to friends. I've spoken to people who never appear on stream. I've spoken to people who behind the scenes sit down in a room with colleagues and actually watch these things after the fact. But the overwhelming consensus is that having every line of code written on stream is beneficial. And to be honest, I started this with the goal of doing everything live on stream. And so I'm going to stick to it. There are people out there that I really hope are going to benefit from learning about it in this way. Some people don't enjoy it as much. They don't have to watch. But yeah, I am going to stick to doing everything live on stream all the way through, at least until V1. So once we get to a V1 and we PR this to Metasploit and it lands, then everyone can have at it. But until we get to V1, it's all going to happen live. Yeah, no, I totally hear you, man. And please don't think that I was dismissing what you were saying. Like, it's certainly a worthy point of discussion. And feedback is always welcome. Yeah, it was a little while ago, but I still think that it's valid. I quiz people behind the scenes pretty regularly. Some people just love the streams regardless of what's in them. Some people prefer content A over content B. Needs to be over 9,000. What needs to be over 9,000? Sorry, I missed something there. Yeah, thanks, At. Well, we are always here, man, and I appreciate you being here and supporting me as always. Okay, so that should hopefully mean that we get a good 10-second wait before it happens again. Well, man, part of the reason that it's entertaining is because all of you folks are involved. It's not just me sitting here not saying anything, which is a huge part of the reason why, you know, I find it so much fun and it's entertaining for me and I learn stuff is because you guys are all part of it too. Thanks, Copper Beardy. I appreciate that, and I agree. I enjoy watching how other people work, and we all learn stuff all the time, which is awesome. Okay, so this time I'm just gonna set this. I'm gonna set a breakpoint here. This is gonna break again, and then I'm gonna set this up. And then once the listener comes back up, hopefully we'll see this happen. We've got to wait the 10 seconds before we try again. And then, okay, we've reconnected. And we wrap. Okay, so the next tricky bit is this, right? Because we're going to say, read the packet. The problem is this. So the header. Now, if we have a look at the header now, where are we? You can see, what do we got here? 1, 2, 3, 4 is all zeros, so there's no XOR key. Now what should be happening over here, so you see we've got a new session. We've sent a bunch of bytes. Now the bytes should contain, what is it? We read the header size in, we get the packet body. What we need to do is effectively at this stage, we need to detect whether or not we are receiving a valid packet. Yeah? So, oop. Here we go. So we need to stop before we get here. Yeah? It's this line here. Now the problem is that this is actually done in the packet itself. But then I think we probably just need to... what do we need to do? We need to indicate whether or not this packet is valid. Because if the packet's not valid, we've got to assume that we need to turf it. The problem that we've got though is when we reconnect to an existing thing, we're probably going to have to do exactly the same as what we did in HTTP, and we actually have a queue of packets that we manage. Oh, we've got another. Oh, we've got a subscriber. Sparkle. Sparkle, thanks for the sub, mate. It's lovely to have you do that and to be on stream again. Haven't seen you for a few streams, I believe. But love your work. Thanks for the support. So what I think we should do is like attempt to read the packet. But in here we basically need to say, you know what, this is not a valid packet, so we effectively need to bail out. The problem though, yes, fellow Australian. The problem that we've got though is when we read that fresh packet, sorry, the stage off the wire, once we reconnect to a staged listener, we know that we're going to get, or we should get, a block of data which consists of the size of the stage, followed by the stage, which contains all of the information at the PE, followed by the configuration. Yeah. And one of the things that I don't like is putting some logic in here that says, you know, we've read some data off the wire. Should we go ahead and treat it one way or another? Because this logic here kind of assumes that we're in a valid context for the packet to be read. So what I'm thinking is that we need to do a check in here, like a peek in some way. And if we're able to peek the data, we know for sure that we're always going to have an XOR encoded packet. And once we've kind of de-XOR'd stuff, that's why the header was 0, because we XOR'd. Yeah, okay, that makes perfect sense to me now. Right, before we do this, I'm gonna run this again. Let me remove all the breakpoints. And make sure that this is built. So the problem we've got is we want to make sure that the header that we receive is legit. We know that the stage that's coming down the wire has always got the first 4 bytes set to the length of the data that's going to follow. We're not going to be sending gigabytes, so it's kind of fair to say that if the first byte is null, then we need to treat that as something completely different. Does that sound like a dodgy hack to you? Because it sounds like one to me. But anyway, what I want to be able to do is this, right? We have a TCP reader dot. Is there a peak? Returns the next available character and does not advance the byte or character position. So what we need to do is, if then we basically want to flush the stage, yeah? We'll leave that in its own little function. So we've got a private void flush stage. We need to detect this on the fly, right? So basically all this means is this. We need to go and read 4 bytes off the wire, just doing exactly what this is. So we can go this.tcp reader.read read int 32. Is that what we do here? So what we got is a size that says read int 32, and then this .tcp reader.read or we want to basically skip. Is there a way of skipping or oops. I've got a reuint, don't I? We'll have to see what this says. But basically what we want to do is go var bytes equals new byte array of size, and then we're just going to have to read. I can't, for some reason I can't seek on this, because if I went basestream.seek, I think that would crap itself. But I kind of also don't want to just allocate something in memory and write to it and then discard it, if that makes sense. But I think that's what I'm going to do just to begin with. This dot read bytes. Oh. Okay, so I can just do this instead and chuck away the result. Okay, so let's see what happens. Because when we're getting legitimate packets off the wire, that first byte should never be null. But I also need to make sure that when we reconnect, which happens here, that first byte is null. Because if endianness is wrong, then I'm screwed. But there's no way we're ever going to send a stage where the very first byte, like the higher order byte on the size of the stage, is going to be non-zero. I know it's a bit of a gross assumption, but right now I think that's pretty much all we've got. That might even be what we do in other implementations as well. Okay. Oops, don't want to kill the session. We want to go exit-y and attempt to do the things. So it's going to attempt to reconnect. Let's restart. Copper Biddy, you're hosting me. Thanks, man. Thanks, man. I say man. I shouldn't assume man, but thanks, my friend. It's very kind. I am very grateful for the host. Okay, so this should end up with the client being wrapped here, yeah? That's good. then we go to the packet dispatch loop and we should end up. Something's busted. That's my assumption, biting me in the boo-boo. Okay, so what I'm going to do this time is I'll set a breakpoint here when I know we're going to reconnect. Sorry, here when we're going to reconnect. Okay, so that means set a breakpoint there. Let's stop. Because it's sitting there waiting for a massive amount of data, yeah? So basically then we want to read 4 bytes off the stream without modifying the contents of the stream. So I wonder if we can actually peek and read more data off than that. Exit dash Y. Transport goes away. Kick that off again. So we'll wrap the client and then we'll do the peak char thing. So I would assume that peak char is going to come back with a non-zero value. Okay, so there you go. So this.tcp reader.peak char -1. Interesting. Danny2201. We're currently building a CLR implementation of Meterpreter, and right now we're trying to implement or re-implement in .NET the ability to reconnect a Meterpreter over TCP that is reaching out to a staged listener, and we're trying to discard the stage. But anyway, that peak char is not doing what I would have expected it to do. So let's see, 0. That's kind of what I was expecting it to be, but it's saying that it's -1. If we look at .NET peak char. Hang on, what type is this again? Binary reader. Binary reader peak char is what we're interested in. So let's just read the docs. The next available character, or -1 if no more characters are available. The stream does not support. Ah, yeah, okay, that'd be it. Pays to read the documentation, doesn't it, hey? So it's going to return -1 every time, so we can't peek. Okay, but that's because we're using a binary reader. So maybe there is something else that we can do. This dot TCP client dot. Okay, gets the amount of data that's been received from the network and is available to read. Okay, so what does the stream give us? So this is a specific type of stream, right? So getStream returns a network stream. We don't have the ability to peek. Let's have a think. I would assume that canSeek would return false. How do I hack Facebook account? Nice troll. Yeah, so let's see. There's got to be a nice way of detecting whether or not that we can peek data on a TCP socket. Redis 2056, thank you for the sub. That's very kind of you. Appreciate the support. Or it might be as Redis rather than Redis. Okay, so what was it that I am trying to do here? We need to be able to read data off the wire, and then if it fits a certain pattern, we basically want to chuck it away. Maybe I should just shove this this whole thing in the packet reader itself. That would actually be easier. It's as much as I don't like mixing what we're doing. So if we instead reused this, right, we attempt to read the header size, because the stage is always going to be bigger than the header size. Yeah, so basically what we need to do... yeah, I'm still not keen on doing this here. Maybe what we need to have is a custom, like, buffered reader. Don't even know whether that makes any sense. Fuzzy Ducks, thank you for the follow. I think what we're going to have to do is put our own reader in place. But I'm not really a fan of that idea as well, because we want to read data off the socket in an abstract sort of sense, and then go, if it looks a certain way, behave slightly differently. But yeah. Trying to think of a nice way of doing this. I'm open to ideas, by the way, if you guys are sitting there going, hey, you should do it this way. .NET TCP peak. Let's see if someone's talking about this. System socket.receive. What is peaking in TCP? How to get the size of TCP available data? How to peak a socket in a synchronous TCP connection. Alright, let's see what happens here. This enumeration has flags are socket flags. Socket flags. Peak. Peak at the incoming message. Really? Get a reply from the server. Ah, hey, that's very interesting. Okay, so if we went this dot TCP client. Hang on, what is that? Is a socket. So dot read. No. Specify socket and send and receive behaviors. What I'd like to know is how we do this. Displays using the overload takes a buffer, message size, and socket flags. So this socket, TCP client, can I get access to the socket? I don't think I can. Bugger. Welcome back, Barney. .NET TCP client get socket. Dot client, is that what it is? TCP client dot. Aha, there's the socket. So then we can call receive, and that takes. Aha, here we go. What should we call this? We'll just call it the peak buffer equals new byte 4. Then what we want to do is we want to receive into peak buffer. Socket flags dot peak. Okay, so what does that return? Receive. So the one that we're doing is this one, and it returns the number of bytes received. Okay. If that equals peak buffer dot length, then oh shit. So what we want to do is, did I delete the flag? Yeah, I did. So if we end up in a case where the peak buffer dot length -1, so the last byte is null, then we want to flush the stage. That's what we need to do. Okay, so let's go back and go private void flush stage. I don't know why I deleted this, to be honest. Fuzzy ducks. Someone really asked for a Facebook hack. Yeah, someone. I assume that it wasn't you. So we want to go var size equals this.tcp reader dot read we'll go int32, and then we'll go this.tcp reader dot read bytes size. So let's do this again. But also we want to make sure that in doing this peaking, that we don't end up killing ourselves. So we want to make sure that that continues to function. All right, so here we go. Okay, so have we managed to peak? Yes, we have. Peak buffer should never have null bytes in it. Alright, so now what I'm going to do is set a breakpoint there, and hopefully everything will continue to function as expected. Here we go. Yeah, looking good. Okay, so BG exit -y. We should see this break. Kick that off. Hit F5. Laying floorboards. Hope that's not a metaphor. So we should see this breakpoint kick in, which is good. We were able to connect straight back into our dispatch loop. Ah, check it out. Flush state. So our peak buffer, see that? There it is. So that's the size. So we want to flush the stage. Now how big is the size? Bingo. And then from here, when we get back here, we should actually see packets behaving themselves. Yay! Okay, it worked. Does that make sense? Alright, so when it comes back up, we should get a connection coming back in just a few seconds. Boom. Sessions-x, it's encrypted. -1, and hey, look at that. What do you know? That's pretty cool, huh? Okay, so what I'm going to do here is I'm going to get rid of that comment. something went wrong connecting, so assume we haven't succeeded and just move on with the transport retry handle functionality. Okay, we've done that. Now we want to do the same thing here. The transport may have bailed while we were trying to read, so return null to indicate a transport error. There we go. Complex number works. Okay, so that would actually, I don't usually like to do the Pokemon pattern thing, but it is what it is. Okay, so if we then go back to HTTP, have I got? Let's see if there's any dot breaks. There's one here. Oh, that's okay. Happy to leave that one there. Okay, so we're now in a position where we have the ability to add transports like on the fly. Well, we're at the point where we can add them on the fly. So let us go through and build that out. Now, what is it that we need to be able to do? Let's go and have a look at the source code in Metasploit. Code, Metasploit framework. We want to go add def command transport in lib. And this is where we'll find the beginnings of it at least. Actually, what we might do is move that over here. Transport. Command transport. Args. List, add, prep, next, remove, etc. Righto, so let's start with... Should we start with listing? We should probably start with listing. That would make a lot more sense because we want to be able to see what the story is. So when we call transport list, where do we find that? Ag def transport list. And that's in client core. We have another follow. Skin Biscuits. What an awesome name. Thank you for the follow. Okay, so transport. Oh, look at that. It's right there. Core transport list. So obviously we are returning a number of things. We're returning groups of all of these things, which is kind of fun. And the active transport is somehow managed internally. Okay, so that's fine. So this is what we're expecting to see. Let's take a copy of that. And let's go over to our server, because this is where we're going to have to add it, given that it's transport specific. Private void. No, not void. That would be a transport set timeout. That's, yeah. Private inline processing. Processing result. Transport list. Packet request. Packet response. Okay, so if gobbledygook and if, let's paste that crap in there so that we can see it. And we will just copy and paste this magic here. Okay, so what it's expecting is the packet at the top level is going to have the session expiry in it. So let's have a look. It'll be this. Transport set timeouts for the current transport. So we're definitely going to need to add what the current transport session expiry is, because that's session level. And so that's the session expiry that we would expect to see. Let's change that to list. Change that to list so that it's actually wired in. Next up, for each one of the transports, we want to create a group. So for each var transport in this dot transport list, oh no, transports. Transport list is the name of a function, which is probably not a great deal, great use of names. But anyway, so we want to go transport packet equals response.add group, and we need to give it the type of trans group. There we go. So we get a group packet. Now, we should probably delegate the responsibility of specifying all the bits and pieces to the transport itself, right? So maybe we should go transport dot I wonder if this, I mean, the config in it will give us the common stuff, but things like proxy, all of that sort of stuff is specific to HTTP/HTTPS transports. But things like comms timeout, all that sort of stuff is universal. So what I should probably do is transport dot what should I call it? Like serialize config or get config? We'll just call it get config. And we'll give it the packet that you should be writing to. So that means we want to generate a method. Okay, so the transport should have a get config. Now, what I'm going to do is inside, you see we've got transport config has one, has a bunch of the stuff in it. So I'm going to put the get config value in here as well, because this is where the common stuff is going to be. Okay. Public transport config. We'll just go here. And so each one of these things we're basically looking to serialize in the same way that the server is serializing it here. We're kind of duplicating functionality a little bit here though, aren't we? Maybe I can let's undo that just for a minute. I don't think that's necessarily the nice. I'm trying to just remove code dupe for obvious reasons. Thing is, we generate, like this add group will return a TLV, which effectively is the same as a packet. A packet and a TLV are effectively the same, but in one case we're adding things. It'd be really nice if we had like an interface that both the packets, maybe that's what we need to do. So in our proto, let's have a look. We've got these functions here. These add and add group. Let's create a TLV interface. Add new item. This could, it's easy to argue this is over engineering, but I don't think it is in this particular case. So TLV. The reason why I'd like to, I'm keen to do this is because I just don't want the code to be duplicated. So I'll make it public for now. And the functions that we want are the add functions. Add group functions. Because these are effectively the same in both the packet. So 40. We can get rid of the publics as well. Okay. Oh, that's right, we've got our own some type there. Okay, so if we've got the interface of ITLV, we also need to be able to specify, where are we? This. Collections.generic. Why is that? Semicolon after method accessor block is not. Oh yeah, we don't need that. Okay, so I should be able to set this packet to an ITLV, and it should just work. And then what I want to do is change the TLV itself to an ITLV, and that should just work too. Does that make sense? Ooh. TLV does not implement this. Ooh, packet results. Yeah, we don't need the packet result implementation because that's too specific. Does not implement it. Add of type. So this one. Does it need to? That's interesting, isn't it? Is that something that I've missed? It is. Okay, so if we go to all of the ads, what happens when I do this? Type or namespace ITLV could not be found. What do you mean it could be found? Oh yeah, I need to add this to the Meterpreter. Add existing item. We need to link that back to Meterpreter ITLV and add as a link. Shoot, just saw the ping. Hope I don't miss too much. Currently at work enjoying a meal and into the stream. Hello, Mr. Lale. I don't recognize that name, so I assume that behind the scenes I know you by another name. Okay, so let's do this. I'm going to go back to get config, but this time when we go to the definition, it's going to, instead of that TLV, it's going to be ITLV. Right? Now this means that these four values here, this response.add, what we can do is in the transport config, we can have our get config now, which takes the TLV that we actually want to write the config to. Public void get config, give it the TLV, and then this stuff here, instead of response, we can go TLV.add. And all we need to do is go D3 F dot. There we go. Nope. D4 F dot. Hang on. Take 1, 2, 3. D3 F dot. Yeah. Okay. Okay. So then here, even though we can do this. This dot current transport dot config dot get config and give it the response and get rid of that. So that means that up here, when we call get config, the transport itself, which in this case, the TCP transport, which needs to implement that function. Where is it? Right down the bottom. I hate it when it does that. I want it to be with all the other public stuff. Let's do it in here. So all we need to do here is we can just delegate this responsibility straight down to the underlying configuration because there's nothing specific to TCP that we need to write. So we can go this.config.getConfig and give it the TLV. Whereas when we do this for the HTTP transport, which you can see we need to implement now, we need to delegate it. We still need to get that, but we need to then add all of our custom stuff. Ah, yes. Thank you. It's nice to see. For some reason, I didn't connect the dots. But thank you for coming on. Thank you for your patronage. Really, really appreciate it, mate. So cheers. Okay, so let's move this up to something a little bit higher. Let's chuck it in here. Okay, so that puts all the common configuration detail in, and then we need to add the other HTTP specific stuff, which we see in here. So we can take this out now. Chuck it there. So that means that the transports know how to write their own configuration, including the underlying. Okay, so we've then written these three things: the com timeout, retry total, retry wait. And so what we need to do now is go tlv.add, tlv type dot transport. Okay, let's do it in order. Oh, hang on, the URL. This is interesting actually, because when we write the transport config here, we write those three, but we don't actually write the URL. But you know what? I'm going to write it anyway. URL this dot URL. Let's just do that. Even though it's not actually used behind the scenes, I don't think that that's going to be too much of a problem. In the case where we're returning configuration items that are only timeout related, they'll just get ignored on the other side, so I don't think that's going to be an issue. But let's go back to here. Okay, so we've got the URL in. So we've got the URL, we want user agent. UA this dot use agent. Okay, so that's the user agent proxy host. Oops. Proxy host. Okay, user pass. Oops. Yes, start. Okay. Proxy pass, cert hash, custom headers. Cert hash, this dot cert hash. Now we should probably check to see if it's null. Mugu, how you going, mate? We should probably check to see if all of these are null, right? We'll do that in just a minute. We'll macro that crap up. Okay, so what do we got last? Custom headers. Headers. This trans headers. This dot custom headers. There we go. Righto, so that should give us all of the stuffs that we're expecting from each of the transports. But what we need to do is make sure that we check each one of these for null and only add them if they're not null. And the only one that we need to vary slightly is the cert hash. So let's go QQ. Not string dot is null or empty. I don't know whether this is going to work. Yeah, because of IntelliSense. That's a bit frustrating. Anyway, we can get a chunk of it done. Is null empty. It's pretty messy. With the autocomplete stuff, that's what mucks it just a little bit. How about we do it slightly differently? No, let's not do that. Not. Yeah, what I need to do is go and change the settings to stop it from auto adding the curly braces in for me, which is a bit annoying. Mugu, Guy Baroni is great. Yeah, how good is his stuff? I'm not gonna lie, like I'm pretty upset that I can't use his stuff. It's seriously good. I just had so much crap when it comes to YouTube blocking my archived videos behind the scenes when I use Guy Baroni as a backing track, which is a real shame because his stuff is really good. Just tired of fights, really. Okay. Get config. Okay, so let's see what this looks like. That should build cleanly. Let's see what happens. Back over here, sessions -1. Ooh, transport list. Show the verbose output of the transport list. Okay, so that makes sense, yeah? Let's see what happens when we do the HTTP version. Okay. HTTP. That worked quite well. A little bit baffled by how well that worked. Sessions -1. Transport list -v. Ooh. URL is all of that nonsense. Comms timeout retry user agent is in there. Cert hash is basically not used. But it looks like that's doing exactly what I want it to do, which is useful to us. And there we go. There's the session expiry there. Which says that it expires, what was that, in a couple of weeks' time? Okay, so that's good. That's good. We can effectively rely on on Meterp to cough up the right detail. We should just check HTTPS as well. Yeah? It was HTTP. This one, transport list -v, HTTPS. Cool. Okay, so that's working as we would like and as we would expect. Oh, actually, let's just quickly check one more thing. Get timeouts. Yeah, that still works fine. Okay, that's cool. I mean, get timeouts effectively gives us the same thing as transport list, but you can set the timeouts while using set timeouts. You can't do that with the transport command. They're kind of in some ways synonymous. Anyway, so okay, so where we got to, we've made sure that our transports are effectively resilient, and we've enabled the ability to list transports. Took a little bit of work, given that we had to deal with some shenanigans. Transport. Okay, so list, add, change, next, prev, and remove. Hello, first time seeing your stream. Adding, follow. Hey, thank you. There you go. Appreciate that, man. Very nice of you to join in. We're pretty close to finishing up for this particular stream. But I'm pretty happy with what it is that we've managed to do. One thing that we haven't done yet is the bind TCP transport, but that will come. So I think what we are going to aim to do on our next stream, we'll yeah, fair enough, man. Thank you for that. We have another follow, Ollie Burstfire. Thank you for that, another follow. Yeah, so next stream what we'll do is we're going to go through and implement these. We're going to have the ability to add, change, next, prev, etc. So behind the scenes we're going to make sure that each of those things are implemented and that we have the ability to flick over transports. At this stage we don't have the ability to do bind TCP, so maybe we need to go and implement that as well. Man, it's a never-ending rabbit hole, really, isn't it? The amount of stuff that we have to do. But hey, it is what it is. Hey, Killix, very nice of you to come in, man. Yeah, you just arrived as we were finishing up. So I did start half an hour early. I'm trying to get on at 7:30, which is 8:30 New South Wales / Victoria time, because of our ridiculous daylight savings differences. And it also means that I finished half an hour earlier and whatnot. Yeah, you did, man, but it is what it is. So I'm not going to go through now and try and add any support for these extra ones. We've got list support. We're ready to sort of fill these gaps out in the next stream. So at this point, I think we'll can it, because I'm not going to be able to implement something in the next 15 minutes. But I think that sets us up for bashing through these features on the next stream. Yeah, watch it on Vimeo, definitely. Vimeo is a much better choice compared to YouTube. So does anyone have any questions? Is there anything that you would like to ask before we bail out? It's actually been, I think it's been quite productive. I think we've got some good stuff done, and we've done a little bit of refactoring, got rid of some code duplication, which is always a good thing. What do you guys think? Is it crap? Do I deserve more chocolate? I think I do. Very good. Thank you. I agree. Alright, well, if you guys don't have any questions, you know you can always hit me up on the Twits. You can drop me an email. You can jump on the Discord channel. Just let me know. I'm more than happy to elaborate further on what we've been doing. But yeah, in the meantime, super grateful for everyone's follows, subscribes, the Patreon supporters in particular. More content coming specific to you very soon. More challenges coming soon as well. But yeah, everyone's support is really great, and having you guys on stream is always really great. It makes a huge difference to the streams, because without you, I think it would suck. In fact, it probably still sucks. But it sucks a lot less with you guys around. You're looking for more. Yeah. Killix, don't worry, most people are asking me for that. They love those ones. And they're coming, because we're still going to do the Pico CTF stuff. We might even do a deep dive into some more advanced binary exploitation stuff down the track. Might do some more kernel related bits and pieces. You know, who knows. But on that note, I will love you and leave you all. Thanks again. And I'll see you on the next stream, which hopefully at the very latest will be in another week's time. I may try and squeeze another one in before then, if at all possible. It just depends on work schedules and responsibilities with family and all that sort of thing. Plus, you know, the Patreons and whatnot need some love, need more love. Crypto stream, hell no. All right, peace. Thanks very much. And in the meantime, be good to each other.